the first circuit among our circuits, which is who? If I come and look here, I will tell you this is the circuit for heating and lighting. Okay, let's first understand how this circuit works, or where this circuit came from, where its supply came from, and then we will see together how the idea will work with me. All right, now the idea is quite simple, essentially speaking. You take one of the feeders from your switch gear, which is 13.8 kV from your station, and you might get another 13.8 kV feeder from another station, basically. Okay, let's just darken the picture a bit. Open it again, in essence. Yes, exactly, 13.8 and 13.8. We come to enter here on a load break switch. Surely, we've all heard this term in RMU, right? Load break switch, LPS, or disconnector switch, if it is totally immersed in SF6 gas. And from here, of course, it might come with a fuse. I'm drawing it for you in general, in the gas, and it exits from here. Of course, it might come with a fuse. I'm drawing it for you in general. Okay, and here it exits to what? To the circuit breaker, all right, and from there it enters what? The transformer. This transformer will convert, of course. Regardless, I'm drawing something perfect for you here, whether in the UAE, in Egypt, or in Saudi Arabia. Someone might use it directly on the feeder to a transformer, or use RMU as you prefer. Okay, this will convert for me from 13.8 kilovolts to 380 volts, 180 volts, all right? Nice. So what are these? Nice. Okay, what happens? You take these ones of yours, and they come to you here like this. Like this. All right, and we come here like this. It goes into a circuit breaker, which is an air circuit breaker, a low voltage circuit breaker. It could be 2,000 amps, 3,000 amps, and in the same way, it also brings me another circuit breaker, and both of them go into a bus between them. A bus section or bus tie, call it whatever we call it. This is an air circuit breaker, so we call this encumber one, all right? And this we call encumber. And here you have what? All right, very good. And I exit from here with a set of, as I will explain to you now, like this, like this, like this. All right, very good. This panel like this. All right, we call this the ACDB, which is the AC distribution board, or you can call it the main ACDB, the main AC distribution board. All right, so you exit from here with an MCCB, all right, from a molded case circuit breaker, and see, for example, I will go to the next. All right, from a molded case, for example. Now I will go to the next. I come here, for example, in the GIS building, I enter here like this, all right. I enter through a molded case circuit breaker. And for example, I can also enter from another bus like this, also through another circuit breaker. And there would be a bus section between them like this. And here I would exit with a set of MCBs, all right? This here is an MCB. Miniature circuit breaker. This here we call the AC board, all right? Or the AC panel. Or this is a panel smaller than this panel. That's why you have an air circuit breaker here. But this one has a molded case circuit breaker specific to it, all right? This is specific. For example, to the 115 kV building. Of course, there might be another one, for example, that could go to the HVAC, and another one might go to the switchgear building, and another one might go to the 380 kV or 550 kV building, or one might go to the 222 kV building, depending on the situation. So each of these circuit breakers comes here and distributes to a slightly smaller panel. All right then, very good. Here, I take my MCB and do PA. This MCB outputs 3 phases, right? Very good. I don't want all 3 phases. I can take the MCB based on this passport as 3 phases and output here with just a single phase. Output with a single phase, all right? So when I come to output with a single phase, I take the red and, for example, the black, all right? Then I come here on the S side, for example, on the first PA, which is D01. All right, and here I have the second bay, and here I keep going with all my cells, one after the other like this. All right, all that happens is that I enter here into a terminal block. All right, then from this terminal block, I go into internal circuits, and from the same terminal block, I exit from here to go to the next cell in this manner. Internally, I go to the group of circuits and exit from here, continuing to the next cell, all of them connected together in parallel. Here you have an internal circuit, here you have an internal circuit, and here you also have an internal circuit. All right, this is the internal wiring here, D01 here, D02 up to, for example, D20, the number of cells you have in the GS cam. All right, someone is asking, Engineer Karim Ali named it DB, which stands for distribution board. Engineer, but since there is still a DC distribution board, I named it AC distribution board, or here ACB, which is the AC panel or distribution board, whatever it is. It's a subsidiary part of it, all right? Distribution board, or here, which is the or the dis or the in, is it a subsidiary part of it, all right? The important thing, as I told you, is that all of these are balanced with each other. However, the AC circuit is not very important to me. It's not that it's unimportant, but I don't need high reliability in it, all right? Good. Let's take a look at what I've drawn here in our drawing. Let me switch back to my camera here. So you'll find what's happening here is that you have a panel. You're in panel number 12, and you'll find that the AC circuit is coming from panel 11, which is the one below, and it's entering us. Then in panel 13, it means it's coming from the panel before me, then I have it, and then it goes to the panel after me. So this is 11, all right? This is 11, the panel coming from the terminal block in it. This is what we call a terminal block. Anything labeled with an X means it's a terminal block, all right? So it's coming from terminal block XA, which is called XA number 1, terminal block, and rosette number 1 and rosette number 4, all right? It's coming to me on terminal block number 1 and number 4. XA, they are all generally similar, all right? I took 2 wires here and used them in my circuit and took 2 other wires to the next cell. If I go to the next cell, I will find it coming from ED12 and going to the next cell, ED14, and we keep going like this, and 4000, so it's a loop, and they are all what? All in parallel. Great, so now I have received the 220 volts, which is single phase red and black, 2.5 mm that we saw earlier, that we compared a while ago. So when I came here, I exited my loop, went like this, and went to a certain symbol, or here and here, a symbol, and here, a symbol. Who is this symbol initially? F. You will find it in the entire drawing. It means MCB, but I don't know. It told you, okay, the thing called F11, where is it located? It's written underneath it. Remember the page I told you we would know everything later as we bring it? It's written underneath it, 23.1. 23 is the page number, and 0.1 is its serial number on the page. Let's see, here I will keep going, I will go to 23. You might say to me, okay, how did you know what 23 is? It's the last page you have, for example, or the penultimate page, or whatever. You have a drawing, all the devils in it are 24 pages. So you go to page 23. Here is what page 23, here is what you have. Page 23, serial number 1. Here, this is serial number 1, and this is page number 23. Okay, come here. In serial number 1, I find this telling me that what is a miniature circuit breaker? Miniature circuit breaker. All right, this is a miniature circuit breaker exactly. And it also lists the maker or manufacturer and the order code, etc. Of course, this is in case you want to get another one like it, or if it has a defect and you want to get one with the same specifications, so you know how to get one with the same specifications. So what am I seeing in front of me? What I'm seeing in front of me is this table, which is essentially what you always hear about, which is the bill of materials. It is a table, and this table contains a serial number for each piece of equipment or item you have, its designation or its number in the drawing, what it's called. Then it gives you a description. Then it tells you which page it is used on, how many of them there are, what type it is, who the manufacturer is, the ordering information, and the country of origin or the place of its manufacture. Therefore, if this item breaks down and you need to buy another one immediately, you will go to ABB and tell them, I want the item with the specifications you have written here, which is an auxiliary contact. 1, normally closed, 2 poles, 16 amperes, 220 volts, type such and such, and its ordering information is such and such. If ABB tells you it's not available, you will go to another manufacturer and compare these specifications with something similar from another manufacturer. All right then, great. Now go back to page 7 where I was. Good, now go back again. So this is an MCB, right? Okay, how is this MCB drawn? Well, if you go back to the Legend of Symbols page, here it is. As I told you, if you go back to it, you'll find here what this symbol looks like. It's drawn here and it tells you it takes the symbol F, which means miniature circuit breaker, or in formal Arabic, the small electrical breaker, or the miniature electrical breaker. All right. But we always refer to it as MCP. All right, nice. So of course the symbol on it is also information for you, meaning you'll find a part that looks like a plus in a square shape, and then in a circular shape. The square shape means one thing, and the circular shape means another. So naturally, the MCP has two protection mechanisms. It prevents short circuits in our control circuits. Also nice. So it takes the AC and distributes it to 3 miniature circuit breakers. What does each one do? It connects to a specific circuit. So when I come to my F22, what do I find here? It connects here to provide you with the line and the neutral. All right, here you have the line and the neutral. You know which ones are the line and the neutral. So I start from the first row. Here's the R and here's the neutral. Of course, the R is the one that comes down from the right side terminal, like this, that's the R, and below is the neutral. As for the AC, it doesn't make a difference to you in anything, all right? Great, so you come in here and come in here. The idea here is very simple. You came here, and every time you move to something, you'll find yourself entering a terminal block, Why? Because you're supposed to have the wiring in any cell. Of course, I don't like to go back. I mean, I don't prefer it, but because some people will find there is a variation, so you'll find some people working and they know what a terminal block is. And some people in this field don't know what a terminal block is. That's why I always used to give recommendations to be prepared for these small issues, because as I mentioned, in the basics but generally the terminal block is any point or anything you move through for entry and exit, you will find a terminal block. Why? To make the measurement process easier for you. When you come to measure, instead of going to the equipment itself, opening the pins and going to the equipment that might have many wires around it and is cramped, making it difficult to measure or even to make an adjustment or do anything, the easiest thing is that everything is available to you. You connect wires to the terminal block, and from the terminal block, you can measure and make modifications. You can connect it with other parts and so on. In addition, each end of any component you have has an MC connector, whether it's standard or non-standard, but that's the correct way, and you can't do anything else. You can't connect more than 2 wires to its terminal. So if you want to connect more wires, what do you do? The terminal block. If you take from here and connect to the terminal block can accommodate 4 wires, 2 from each side, meaning the terminal block from each side. You can't connect more than 2 wires to it, 4 wires. Thus, this terminal creates 4 paths. Conversely, some terminal blocks have 2 stages, each with 4 outputs. A 2-stage block acts like 2 blocks, connecting 8 wires to one place, right? Of course, this depends on the use in the computer circuits. The important thing is I came here, terminal block A, and terminal block A. I entered here into something called DS1 and something called DS2. I don't know who these are. So I go to page 23B, 708 and 71, or sometimes I find here that it tells you who DS1 and DS2 are. So of course, it wrote DS1 and DS2 and told you this is the role of the switch for LCC. What does the role of the switch for LCC mean? If you come here to the beginning of the panel, here's your LCC. All right, the doors you have, this door and that door, on the back of the door, if you open the door, you'll find inside something called a limit switch, like the one in a refrigerator, for example, for the light in the refrigerator or others. The idea is very simple. The limit switch, as you can see, is drawn as normally closed, meaning it's connected or on a normally closed contact. Now focus with me from here on. Anything I tell you about my rule, what does it mean? It means the switch role of the LCC cells is drawn with its specific context while the door is open. It means the contact is closed in front of you now based on the fact that the LCC door is open. As long as the door is open, it will pass the subline from here and pass the subline from here. Whether you open the right door or the left door, either one of them, I know, will pass the AC from above here, go here and go here, activating E1 and E2 for you. Who are E1 and E2? It's simple. I come here and find them. If I don't find them, what do? I immediately go to page 23.com.8. So of course I quickly go to 23. I know they are for the circuit, but I'm just showing you, all right? 23.8, here E1 and E2 are the illuminate lamps, which are 20 watt, 60 hertz bulbs. What do they revolve around? They revolve around material that tells you it's a Philips bulb or something like that. So what does this mean? It means this circuit is the one that operates the bulbs of your cell in case the cell door is open. So as soon as you open the door, the necessary bulbs inside light up with you, and this allows you during maintenance work or troubleshooting to see the internal parts of your cell. All right, great. All right, let's move on. After I've seen this circle, it means bash and nazil, that I now have the neutral reaching up to this point and up to this point. Consider it like the light switch you have at home. Now you have this reaching here as neutral and here as neutral. What do you need? You just need the live, which is the phase R. So of course, as soon as you open the door, your code is now normal close, and it will pass you the live here and pass it here. All right, you've closed both contacts. This contact will be open and this contact will be open, and consequently, it will cut off the supply here and cut off the supply here, and therefore, both lights will be off. All right? Great, excellent. So what is this last part? This last part is the first application we will get to know related to the actuator, which is the AC supervision. It's something that monitors your circuit. What does that mean? As you can see, this part in front of you, any actuator drawn in front of you in the circuit labeled A1, A2, that means these are the coil terminals. All right, it's definitely not a contact, meaning this is not a contact diagram. So as you can see, the AC supply is connected here from the top and here from the bottom. This means it is energized all the time. Why? Because if there is a break in the circuit, in any part of your circuit, in the direction of the line or in the direction of the neutral here, this coil will immediately drop off. By using its auxiliary contacts, normally open and normally closed, I can send you an alarm to the annunciator, to the CS, to the SCADA, telling you there's a problem in the AC circuit. So this is called AC supervision. Always, any supervision must be present at the end of your circuit. That's right, it's not forgotten. Supervision is always at the end of your circuit. It can't be in the middle because it won't be able to see what's after it. It must be at the end of the circuit to supervise everything that comes before it. Following that, it's clear and nice. So the first thing we've learned now is that the switch is normally closed when it's open. Great. Now let's move on to other circuits. Let's take a look at these partial circuits above. These are the heater circuits. What does that mean? Let's see together. Now I will also take my AC, all right? And here you have the line and here you have the neutral out. That's clear and nice. So the line comes here, connects here, connects here, connects here, and so on. And the neutral from below also connects here across all my loops. All right. Let's move to this first part. This is the section for my heater, all right? As you can see, I come and select the supply. Here you have the lower part. This is the HD heater. How do you know? You will immediately go to the material, page 23, and you will find HD as an abbreviation for heater, which is 100 watts, 500 ohms. All right, what is this heater used for, guys? This heater is used in case you have any humidity inside, meaning moisture inside your panel. So it doesn't accumulate on the wires and such. The temperature of the cells inside must be under a certain temperature for the purpose of humidity. So I raise the temperature to prevent the presence of humidity inside the panel. All right, great. Now this heater currently has the neutral connected. What does it need? It needs to receive a supply from above and so on. This heater and this heater and this heater and so on. So where is this heater located? It's located in the LCC panel. All right. And where is this heater located? No, it's not in the LCC panel. It's drawn normally, but this one is drawn with a dashed line around it and placed inside a black square box. We agreed that when you have a dashed line like this and inside a black square box. What does it mean? It means that the item inside the box is coming from a mechanism box specific to equipment located in the GIS, not in the LCC panel. So what is this equipment? Of course, the name of the equipment is written for you, like A611, D607K, K630, and so on. Naturally, A611 is the breaker number here. This is the number for the 3-position switch of the upper disconnector. And here's the number for the lower disconnector and so on. All right, so how did you know? No, I don't have it memorized, but through the single line diagram, you will see them in a bit. All right, great, nice. All right, this heater and that heater, they are all connected to the neutral, waiting for the booster from above. As for the heater, where is this heater located? It is located in the mechanism box of the breaker, and this is the mechanism box of the 3-position switch, and this is the mechanism box of the other disconnector, and so on. Oh, right, because each mechanism box also contains some control circuits and a motor inside, so they also need to have a heater, right? Your main heater here for your cell, how does it operate? Well, your supply will come here, pass through here, and pass through here. What do you have here? The HST, which stands for humidity state, means that you adjust it here according to the level of humidity. You set a specific humidity level, and if the humidity setting or the humidity reaches this limit, there is, of course, an internal sensor. As soon as it measures that the humidity reaches a certain level, what does it do? It closes its contact. So immediately the supply passes through your heater here. And your heater, what does it do? It turns on completely. Okay? What about another one? The other one, what's its deal? It passes through here, and this is your thermostat. Your thermostat has more than one position depending on how you want it. Manual, or you have something like a thermostat switch. If you want it manual. Manual means you handle the supply from here like this. You see where your contact is closed here. It will transfer it here. So it brings the supply directly to the heater. You keep monitoring the temperature yourself and turn off the heater whenever you want. And of course, this doesn't account for the other position here, which is off. The third position is auto. All right, so this is like what's inside the thermostat. Either it's manual or auto. If you set it to auto, you'll find it goes down here waiting for your thermostat. So you set your temperature to 50 degrees, 60 degrees, 70 degrees. Based on that, whenever the temperature drops below it, this contact closes, changes its position, and allows the current to pass through. The heater starts working. When the temperature reaches the set point, the thermostat here will turn off like a kettle or a water heater in bathrooms, whatever it is. The idea is the same for all of them. Of course, let's not forget that. As you can see here, this means that the switch's default position is as shown in front of you. It's in the off position, not set to manual or auto. As for the others, it's the same thing with your thermostat. It's either manual, off, or auto. You adjust them according to the situation at your station, depending on the client, meaning according to your client's needs. It's clear, right? So this is the heater section. In the end, what will I find? I'll also find the superheat, or let's say, the important thing is that its coil is always placed on the AC circuit. It should be running all the time. So when there's a break in any part of your loop here, any break in your loop. All right, whether it's from the line side or the neutral side, it will immediately drop off. So its context changes or weakens. You use it as an alarm. So where is it, sir? Aren't you good with alarms? I'll show you when we read the alarms on the launcher or on the PLC. We'll see it together. It's clear, very good. And here in this section, you have the MCB. As you can see here, all the MCBs are depicted in the open position. Their normal case is open. Great. So all the MCBs are depicted in the open position. Very good. Here we come to this third section or circuit, where you have the supply at the top and the neutral at the bottom. Here, it's just connected like a socket, which we call socket 1, and you have socket 2. What's its purpose? Well, when the cleaning crew comes with a blower to clean the cell, they need a supply to charge something, to run a blower, to run a laptop, or anything else. There should be a socket with 222 volts in condition 22. Additionally, here, we will take the supply. We will discuss the amplifier when we get to it, God willing, in Ishiba's operation. Super quick.